Hello, my name is Paul Garside and I work at the Kelvin Centre for Conservation and Cultural Heritage Research, which is based at Kelvin Hall and is part of the University of Glasgow. At the Kelvin Centre we study conservation, technical art history, dress and textile history and conservation science to help us understand and preserve physical objects associated with our cultural heritage, particularly artworks, textiles and modern materials. Our research supports the work of museums, galleries and archives. We're going to have a look at the ways in which light can interact with these types of objects and materials and the sorts of damage and changes it can cause. We'll also think about how we can protect our cultural heritage by understanding these changes. A particularly important feature of objects is their colour. It plays a big role in how we appreciate and understand the things we see in the world around us, including the sorts of objects we might look at in a museum or a gallery. Objects that are exposed to light change colour over time. You've probably seen this with curtains that have faded and the spines of books which are now a different colour to the rest of the cover. When these colours change, it can spoil our appreciation of the objects and can change the way in which we can understand them. So we've seen that colours change and fade, but why do they do this? And why don't all colours fade in the same way? All things change over time, and if those changes are unwanted, we tend to think of them as damage or degradation. There are many different factors that can cause these kinds of changes, and they're often referred to as the 10 agents of deterioration. Light or radiation is one of these agents. When materials are damaged by light, we call this photodegradation. We've seen some examples of this happening with day-to-day objects like books and curtains, but it can also happen with paintings and other objects in museums and galleries. We can see some examples here where a print, the binding of a book and a wooden surface have all suffered damage from light. We can see that the colours have faded and changed. Light is part of the electromagnetic spectrum. We can only see a small part of this spectrum. This is the part we call visible light, but we're familiar with other parts of the spectrum too. We know about ultraviolet light, for example, because we know that we don't want to be exposed to too much of it when we're out in the sun. Ultraviolet light can be very damaging to museum objects too. We know about infrared light because although we can't see it, we can experience it as warmth that radiates from a hot surface. And other parts of the spectrum are also important in our day-to-day lives. Radio waves, microwaves and X-rays are all part of the electromagnetic spectrum. We often refer to visible light as white light. Each different part or wavelength of visible light represents a different colour, and when we see them all together, we see this as colourless or white light. We can split white light into the different colours that make it up using, for example, a glass prism. This is also the effect we see when there's a rainbow. Water droplets in the air act as prisms and split the light into the different colours we see. Coloured materials and objects interact with visible light in different ways. They absorb some of the parts of the white light and reflect others, leading to the colours we see. We can think about this with a couple of examples. Here we have a blue object and an observer. When white light shines onto the object, and remember that white light is made up of all of the colours we can see, some of the light is absorbed and some is reflected. A blue object will absorb green, yellow and red light and reflect blue light, which is what we see. If we think about a yellow object instead, it will absorb the blue and red parts of the light and reflect yellow light, again, which is what we see. Why does this happen? The colours we see in objects are linked to their underlying chemistry, and there are different types of effect that cause colour. If we think about organic molecules, the colours we see are the result of special chemical structures called chromophores. These are sequences of single and double chemical bonds which can interact with visible light, absorbing some colours or wavelengths and allowing others to reflect. We can see two examples of organic molecules here that have a red appearance. Lycopene is the red chemical that makes tomatoes red, and alizarin is a red dye made from the madder plant. Historically, this was very important for dyeing textiles. When photodegradation occurs, the light that's absorbed by a material causes chemical reactions to occur that change the colour-giving molecules. As they change, they lose their ability to interact with light in the same way, and so their colour changes or is lost. This means that the colour of the object as a whole will fade or change. Ultraviolet light is particularly damaging. Not all coloured materials behave in the same way when exposed to light. Some fade quickly, others are more resistant and keep their colour even when they've been exposed to light for a long time. We can look at this with a simple experiment. For this experiment you'll need the following: a colourful page from a magazine, leaflet or newspaper, and you can see two examples here, a sunny window and some adhesive tape. Cut the page you've chosen in half. You're going to expose one half to light, but keep the other half separately so you can compare them at the end of the experiment. This second half is called the control sample. It lets us easily see what changes have occurred. Take the first half and tape it to the inside of a window, with the image facing outward. Place the control sample in an envelope or folder or somewhere else safe out of direct sunlight. You'll now need to leave it for several weeks. As the page is exposed to sunlight, it will gradually fade and change. How quickly this happens will depend on how sunny it is. Bright light will make things fade much more quickly. You'll probably need to leave your sample for a few weeks before you start to see changes. If you look at your sample after a few weeks and compare it to the control, what has happened? You'll probably see that there are changes, like the examples you can see on the screen here. In my examples, you'll see that the yellow and red colours have faded a lot, but that the blue hasn't changed much at all. And overall, they look more faded and dull compared to the control examples. This is often what happens. Not all pigments and inks are sensitive to light, so some of them keep their colours well. For printing inks, reds and yellows are often the first to change. Blues generally change more slowly, however, and black ink tends to be much more stable and doesn't change very much. What do you see in your samples? What might this tell you about the inks that have been used? We can use this information to help look after paintings and textiles in museums and galleries. We want to be able to keep them for as long as possible, but we also want to be able to see them when we visit exhibitions. If we kept them in the dark, we'd stop light damage from happening, but also we wouldn't be able to see them. So we have to come up with a compromise. How do we make these decisions? There are different ways we can do this. We can make sure that we use light sources that will minimise damage. The most damage is caused by ultraviolet light, so we can either use artificial light that contains no ultraviolet, or if we're relying on sunlight, we can add filters to windows to block out the ultraviolet light. We can also make sure that the light isn't too bright. The brighter the light, the more quickly fading will occur. However, we also need to make sure that there's enough light so that visitors can see the objects. We can limit the length of time that a light-sensitive object is on display. We can also understand how materials change when they're exposed to light. The properties of some pigments, inks and dyes are well known, so we can predict what's likely to happen when objects that contain these are exposed to light. But we can also carry out a similar experiment to the one we thought about earlier. To do this, we use a special piece of equipment called a microfader. This exposes a tiny area of an object to a bright light for a short period of time and measures how the colours change. Unlike our previous experiment, this change is too small for us to see, but it can be measured by the equipment. When we know how these changes happen, we can then understand how sensitive the object is to light, and we can use that to make sensible decisions about how it's displayed and for how long. This has been a quick introduction to some of the ways in which light can interact with coloured materials and artworks and the changes it might cause. Hopefully it's also introduced the ideas of how we can use this information to better understand these changes and to make predictions for the future to protect artworks and other cultural heritage artefacts. Thank you very much for watching.